Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our JNCIS-SP certification course. Today we discuss filter-based forwarding. Basically, what is the reason or why we use filter-based forwarding? The concept is like this. Consider this router is a customer router, and this is a service provider router. Okay. It can be a single router or it can be multiple router. I show here single router. It can be multiple. ISP1, ISP2. Okay. In last class, we have checked how to load balance between multiple physical port. Uh, but this scenario is this is customer router. There is no access in service provider router. Okay, so service provider router have service provider administration access, and customer router have customer access. So if we need to send traffic like customer B1, this PC traffic will be travel through this link, and this PC traffic travels through this link. Okay, that is called you can say it's a PBL, policy based routing. Okay, policy based routing. Juniper here, this consideration is called filter based forwarding. Filter based forwarding. To deploy this concept in this lab, we just we reconfigure this device now and ready our lab for checking the filter based forwarding. Okay. First one, router one. Sure. This concept. There is load balancing configuration here. I remove this one. Load balancing configuration. Delete. And delete the hash key. Delete. You can delete policy also, or you can keep this policy. Much. Same way, I delete from support, delete hash key. Another one is logs. Okay, so widespread routing protocol will be removed. Only it is now. Fiber code. This that. So here is physical interface configuration. There's multiple interface connected in Juniper router 1 and the passive configuration. IPv4 and v6, there is loopback interface. Only address configuration completed here. Similarly, in router 2, to discuss them. In router 2, widespread remote. So first one, I have to make reachability. I have to make reachability. That means this PC customer B1 can raise BPC3. Also, customer A1 can raise BPC3. So I use here static routing in customer in, and this router will be the service provider router. This service provider router, they are making the BGP configuration with their API stream. Router 3 is the API stream. Okay. So here we configure the eBGP, and here we configure the uh, static routing from Juniper router 1. Or we can configure BGP, no issue. You can configure BGP, no issue. Okay. So simply we take here the ASN 100 and this ASN is 200, and I choose here the ASN is this customer router use service provider prefixes. In that case, we can choose private ASN. Okay. So here private ASN for customer router. ASN duplicate. Consider here ASN 646451 is the private ASN. Okay, is the private ASN, but need to need to configure. I here IP address is private. Point to point, it can be private, but PC subnet should be in public address. Okay, this is a lab. I consider 10.1.4.0/24 is a public address, or you can change it. Okay, you can change it. So starting from router one is number set routing options, start routing options, autonomous system 64513, set routing options, router, router ID. Router ID is this one, enter one, and we configure the BGP between router 2. So set edit protocol BGP group. I mention here ISP, ISP1. So this is a eBGP configuration. So set type is external and set neighbor. Our two interfaces here. One interface is C0/0 and another interface is C0/0. Two. So one neighbor is this one. Description is ISP one. We are primary. Local address. Local address is one. Local address is one. And set neighbor 10. PRS is 200. And need a policy. Set neighbor 10. Export policy. Need export policy. Like allow all. You can mention any name, exit, edit policy option policy statement, allow all. I set here all accepted, set from 100, then accept. I'm sending all route from here. Okay. So this is a single neighbor. So need to complete another neighbor. This is secondary. Copy neighbor 10 to neighbor. Another neighbor will be 10,104 is the subnet. Another neighbor will be 6. And others parameter will be except local address. Others parameter will be PRAS export will be sent. Change description and the local address. So local address will be 5. And set the description. Description is ISP R1. This is the very simplest BGP configuration, eBGP configuration. Make BGP configuration here, edit protocol, BGP, go, customer A. Set type, external, set neighbor, set neighbor, my neighbor will be 1, description, so customer A. Customer A, you can say primary, and local address will be 2, PRS, PRS will be 64512, and export default. Default, default, default. That is default route default. Copy neighbor 10.1 to neighbor. Secondary neighbor will be 5. Sure. Set 10.1.5. Local address will be 10.1.0.6. And description will be secondary. Description will be secondary. So default edit policy policy statement. This is the default. Show set down 0, set down 100 from route filter 0 by 0 accept, then accept other than reject. So one show route, this one exact. This route is not available here. So need to set discard route for sending the default route. Okay. Set routing options, static route 0 by 0, discard, and the preference will be done. Checking the route from default route is available here. So check from customer end. Customer getting default route from BG. Okay. So need to check This two route is coming in Juniper router 2 or not. So, number one is 10.1.4.0/24. This route is coming for primary and secondary link. Okay. Another route is 1.0, that is this PC 10.1.0. Similarly, this route is coming for primary and secondary next hop. Now need to check this route is coming in router 3 or not. No, this route is not coming in router 3. I will show BGP summary. There is no BGP configuration here. Checking. Show this plus that. Interface is 3. 3 interface IPv4 and D6 IP address configuration. Have and some policy here, but in BGP configuration, maybe edit protocol in BGP group. I think BGP maybe you can set the group name ASN 100, set type external, set neighbor. What will be your neighbor? Interface 3. So this will be your neighbor 10. Description as 100 and set local address will be 9 and PRS will be 100. Export all error. It's a lab just for checking the filter-based forwarding. That's why we give less importance in policy. Set RAM 100. That's okay. So every route will be accepted through this policy. Juniper router 3, edit before going to BGP. Check the enter configuration first. The back address setting here, autonomous system, router ID, but BGP configuration ring. Okay, edit protocol to BGP group ASN to set type external, set neighbor. My neighbor will be 9. Neighbor will be 9. Description ASN local address 10 and PRS 200. Okay, so if I send default out from here, that will be okay for customer, I think. So set neighbor 10 export default that will be default IPv4. Default route IPv4. You choose what will be the name. Okay. Reception policy statement before then set down 100 from your filter 0/0 exact then accept set 1000 then rest. That's okay. So need default offset routing options static route 0 by 0, discard reference will be 2. That's okay. Check run show route 0 by 0, reject. I'm getting default route, so static. Run show BGP summary. Okay, BGP now up. I think yes. Default route. What is the problem? Coming and going. Coming and going. Any issue? Delete. Routing options started route 0 by 0. Delete. Is there BGP flag? 40-second, 45, 50, 52, 54, no. BGP session, 1 minute. It's okay. But now check the default route. Yes, default route coming here around 17 seconds. Okay, so checking from customer PC, my source will be this one, and this one will be the source, and my destination will be this. Just checking this accessibility. It's working on not. BPC3 show this is the BPC3 IP address is this one. So test from customer one. Internet slow or something. Okay, this is the regular event. Okay, so back to our lab. Customer A, customer B, and BPC3 IP address is this one. Want to send packet. Ping. Yes, getting ping. It's working. Customer A. Yes, it's working. And what is the path? Trace route. So this is the path. Checking from customer A1. Check here. The path first of is 10111. This first of is 10141. That means this subnet gateway and this is subnet gateway. There is two different interfaces. Okay, that's fine. Different. And second second line, you see 10102. That means this will go through C 0 by 0 by 0. And see the another trace 10102. This also going to Z 0 by 0 by 0. Okay. And another IP is 10110. That means router 2 and router 3. This is basically same, and this is also basically same. So only here path two, interest path, position two, this is, there is alternative path. There is alternative path. You can say there is one is the primary path, another one is the secondary path. Both PC traffic travels through the primary path, travels through or via the primary path. So if you want to um, configure, or if you want to deploy something like this, uh, customer A1 will be traveled through the primary path and customer B1 will be traveled through the secondary path. Okay, for this, you policy, need policy or PBL, policy based routing. You need PBL. So our today's topics is policy, how to make PBL, policy based routing. In Juniper, this called filter based forward. This term is called filter based forward. See here, our traditional routing, if I send packet from LAN to internet, there is multiple service provider, ISP A and ISP B. So every packet is traveled through the primary ISP. If primary ISP goes down, those traffic will be traveled through secondary ISP, that means ISP-B. It's the traditional packet forwarding apps. So if you want to use multiple, if you want to use both ISP-A and ISP-B, so if you want to do this, you need to configure filter-based forwarding. Okay, filter-based forwarding support both IPv4 and V6. Filter-based forwarding configuration, there is basically 3 steps we have to follow to configure filter-based forwarding. Number one is creating a mesh filter. Number one, you have to create a filter. Number two, you have to create a routing instance. Those routing instance role will be the forwarding role. Third one is creating a RIB group. So RIB group basically link or share routes between global routing table to customize routing instances. So there is 3 steps here you have to follow to complete the filter-based forwarding concept. Okay. So how to create the mesh filter? So set the firewall. If you want to create firewall filter based on IPv4, you can follow this structure. Set firewall filter, firewall family INet filter, then set the filter name, then term, set the term name, and you set the condition. What will be your source and what will be your destination? If you like not mention any source and destination, that will be all source will be mass here, all destination will be mass here. If you mention here a specific source, those source will be mass only. But by default, if you don't make any mass here, all will be allowed. Okay. Then routing instance and set the routing instance name. So this is the process of configuring the mesh firewall filter. Very simplest way. Is there another way? Basically similar way. And this is the example. Step 2, routing instance. How to create the routing instance. Set routing instance and set the instance name. Instance type will be forwarding. And you can set your static route. You can set your static route under routing instances to mention the ISP next hop. So this is the second step, how to create the routing instances. After creating the routing instances, this is also example of creating how to create the routing instances. And third one is um, next. Third one is create the RIB group. Create the RIB group. So RIB group uh, basically share routes between routing instances. It can be master to customized routing instances, or it can be custom routing instances to master routing instances. Okay, so we show here how to create filter-based forwarding. There is basically three steps. First one is create the firewall filter. Second one is create the routing instance. And third one is create the RIP group. Okay, so starting from step one, like edit, maybe internet issue. The internet. Okay. Edit firewall. You can say here filter, define an IPv4 firewall filter, or you can also mention the family. Okay, family, and family will be inet for IPv4, inet6 for IPv6. And keyword is filter, then you can set the filter name. Filter name will be, you can choose here LAN PB. The filter name is LAN PB. So you are in LAN PBR filter and set here your logic. Set here your logic. Set RAM, you set the rule name. I set your name is 100 and you have to mess through the from keyword and you have to set action through the then. Okay. So set RAM 100 from source address. My two subnet is in my LAN. One subnet is 10.110/24, another one is 10.1.4.0/24. So I mentioned here first one, 10.1.1.0/24. This is my first one source. And set here another term is 200 from source address 10.1.4 10.1.4.0/24. So what will be the action? Set term 100, then set term 100, then you can take a action. You can take an action. So action will be, you can set here, next IP. There will be one option here. Next interface, that will be one option. Okay. Another option is routing instance. Routing instance. So first I set here next IP. So what will be the next IP? The next IP will be for 100 RAM. I want to send this packet through the primary link. So primary link next IP will be 10.1.0.2 and term 200, then next IP 6. So this is your condition. Your condition is if source 1.024, the next IP will be primary. If source is 4.0, next IP will be secondary. Other than this, set term 1000, then X. Others traffic will follow the router default route table. Follow the router default route table. So this is my filter. See here how to create the filter. Filter have basically two options. One is from, you have to match source or destination. It can be address or it can be protocol or it can be port. And here is the action. Okay. And set this filter in LAN interface, that means incoming interface. Set interface CE 0 by 1 unit 0 family inet filter input and say here the filter is this. And another interface is 3. Another interface is 3. So comment this one. Now sending packet from this PC. Say here P1 10102 and customer A1. Anything change here? Nothing, right? But have to change. 10102 and this one is 10102. Maybe getting from cache. Okay. Now checking. I'm sure interface 0 by 3. Commit. So nice. That should work. Source address 10.1.1.0, 10.1.1.0.24. Next up will be this one. And 10.1.4.0, 10.1.4.0.24. Next up will be this one. Other traffic will be accepted. I applied here. Okay. Input. Show route 0 by 0. Default route getting from primary and secondary. This is okay. But my next step will not change here. Set interface G is 0 by 0 disable commit checking the BGP. This is the alternative route. 06. This is coming automatically. 06. Okay. Mm, delete the disable command from it. 10102. 10102. Uh, from source address this one. Next IP 10102. 10106. Condition is okay, but this is not working. So what can be the solution? Okay. After making the firewall filter, you have to apply the interface that it's an incoming interface. Okay, online interface. You apply the direction will be input. Apply this filter. If you check from customer B1, this prefix is 4.0. This packet will be traveled through 10106 and 1.024. This source packet will be traveled through 10102. So this the keyword is next IP. Keyword is next IP. Okay, and you can send packet from customer B1, but in our virtual lab, this both packet will travel through single path. Travel through single path. So this is the basically this is the one way to send packet based on source. If source this, next up will be this one. So another way we can define here. Then we can also use next interface. Next interface. Packets are to be routed through the specified interface. So you can mention the interface name here. So if you want to mention the interface name, so I set here from 100. For from 100, next up will be 10102. And this interface will be 10102. Interface will be 001. 001. And for from 200, the interface will be 3. Interface will be 3. Show mass LAN period in this plus next interface. We can also use this one, next interface. So if I check from this going to 1.02, this is also going to 10102. Basically, both are not working here. But in real hardware, it will work. Okay. In our today's filter-based forwarding is first one is create the filter. First one is create the filter. Second one is create the routing instances. Create the routing instances. Okay. Again, check. So this let's say any load balancing method. No. No load balancing method here. Okay. So edit routing instances. I can set here primary path. Routing instance name is primary path. Set instance type. Instance type will be forwarding instance. There is no need to include the physical interface here. So set the static route, set routing options static route 0 by 0, that is default route, and the next up will be 02. Next up will be 02. So this is the routing instance. Routing instance name is primary path, and inside routing instance, you are declaring the default route. Comment this one. Run show route 0 by 0. Exact. See here, default route is only in master table, inet.0, but not in your routing instances, because these routing instances have no interface. They don't reach this next of IP. That's why these routing instances not create the default route in inside the routing instances. So create the another routing instances, or you can copy routing instances primary path to routing instances secondary path. SCC created secondary. So there is another routing instances here, routing instances secondary path, and their next up will be changed. Set routing options static route, that will be default, but next up will be second path. Second path next time. That will be 6. There is, so need to remove last one. Delete routing options static route next time. Route next time, and last next up will be deleted. So I create here two routing instances. You can say first one is for ISP1 and second one is for ISP2. I use here multiple link. So first one is primary path and second one is secondary path.
Huh? Hmm?
Okay. And edit firewall filter family inet firewall family inet filter, and your filter name is LAN PV. So you can address your routing instances set from 100, then routing instance, first one is primary path, and from 200 to address the routing instance is, oh, sorry, this is wrong, secondary path. And primary path, previous primary path in term 200 will be deleted. Okay. So see here, if source address is this one, the routing routing is for next hop, routing instance will be primary path. For this source, to take the next hop, choose the secondary path routing instances. Okay. Then go to the routing instances and checking the default route. If default route have next hop, this packet will take those next hop to send the packet. So I have created two steps. One step is firewall filter and another one is routing instances. So we need last one step RIP groups. Run show route 0 by 0 exact. So master route table have only default route. Others routing instances have not the default route. For this, you have to create the RIP groups. Edit routing options, then show there is router ID and autonomous system configure. So first one is you have to share the interface route first. Interface routes, RIP group, INET for IPv4, and you have to set the group name. So set here interface routes and interface routes, then RIP group, and set INET for IPv4 and IPv4 routing table group. IPv4 routing table group. My RIP GLP1. My RIP group 1. This is your RIP group name. This is your RIP group name. So set RIP groups. Your group name is my RIP group and you want to import. Last class I show you the import policy. Import RIP and you need to copy. You need to copy interface. All interface in router 1, all interface route is in global route table or master route table. So we need to share the route with the routing instances. Okay. So import RIP, the source route table is inet.0. Source route table is inet.0. And next route table will be the primary path dot inet dot 0 is the first one, or we can take from here. Run show route routing table is only two. Run show route table is inet.0. Primary path inet.0. Import RIP. I can mention here bracket for multiple. Okay. So primary path inet.0. Practice. And show now my route table. This table yet not create. This is the reason. Mute and show route Let not create the route table. Line.0. Edit routing instances. Primary underscore path. Secondary underscore path. Edit routing options. Then show set RIB groups. My RIB group 1. Import RIB. Line.0. Primary path. Checking edit routing instances. So set interface edit primary path. So set interface level 0 commit. It is allowed under forwarding instance. It will not take. Image primary path dot table will be checking from another set routing instances. Instance name BR1 instance type button. Okay. Then interface level 0. Run show run table. Table name is br1.inet.c. Yes. Name then dot then G. So here the name will be edit routing options. So set RIB groups. My RIB group 1. Then import RIB the table primary path dot inet dot 0. And second one is secondary path. Why is secondary? Routing instance. Secondary path dot inet dot 0. Okay. Commit this one. Okay. Then checking. This means inet dot 0 interface route will be copied to primary path inet dot 0 and secondary path inet dot 0. Okay. After that, if you check default route will be master route table, these routing instances, primary path routing instances, and secondary path routing instances. Okay. So every master route and customized routing instances have default route. If you want to send packet now, see here 10106. This is coming from customer B1 and this is coming from customer A1. Yes, this is working perfectly. This is going to 6 and this is going to 2. This source this source, that means customer A1, this source follow the primary path, this routing instances, and customer B1 follow this routing instances. The next up is 10106. This is called the filter based forward. Clear? So I share the step again. First one. First one is you have to create the filter, firewall filter. You have to create the firewall filter and you have to mention your massing traffic and which routing instance will be select for this massing traffic. Again, select the massing traffic and choose which routing instance will be for this source. And this is the default. You have to make this one. Otherwise, your packet will be dropped. Others packet will be dropped. So this is the firewall filter. I'm attesting here routing instances. So second step is need to create the routing instances. This is the first one, primary path routing instance and instance type is forwarding and set the default route, including the next one. And again, configure the secondary path, instance type forwarding, including the secondary path next one. Okay. Here you mention the default route, primary and secondary path, but this default route will not activate because these routing instances have no interfaces, routes here. That's why they didn't reach this next hop. Don't reach this next hop or will not reach this next hop. Okay. That's why they will not create the default route. For this, we need the RIB. RIB will help to do this. RIB will share the interface routes in this group. And this group basically copy master route table to custom routing instances. Which route will be coming here? Custom routing instances. So which route will be coming here? Interface route will be coming here. Okay. If you check now, run show route, see here, this is the routing instances. See here, the default route and all other route is direct and local. See here, primary, default route, and another all route is direct and local. Only interface routes is copied here. And this interface route also available in master route table. So could you find the tricks? Why we do this? So, and this is the filter based forwarding. So in ours, in this slide, basically see the same thing. Just configure the firewall filter and attach the routing instances. And second step is the massing filter. This is basically step one. And this is step two, routing instances. And last step is create the RIB groups. This is the example of RIB groups. Create the RIB group, set the group name, and import master route table to customize routing instance route table. So this is the checking multiple route table. You can check show route table and your route table will be coming here. So this is the verification. If you send packet from this source for our topology, if you send packet from customer A1, packet will go through the primary link. And if you send packet from 4.0, that means customer B1, those packet will travel through the secondary link. Or you can say second ISP or ISP2. Is then accept other traffic will be allowed. So this is all are the example. And there is another option here. If you don't want to use RIB groups, if you think RIB groups is complex, in that case, you have another options. Okay, you have another options. That is instance import. That is instance import. Okay, a policy-based alternative to using RIB groups for the instance route sharing. Using the instance import options helps overcome these limitations. Okay. Okay. Then this is the basically instance import feature. Lack of intuitiveness, more intuitive than RIB groups in some situation. Complex configuration requirements, less complex configuration requirements for instance import, redundancy, information imported and exported by the routing table groups is already present in the router and can be reduced from most configuration for protocol configuration. Routing table groups must be applied to every protocol containing routes designed for export. For RIB groups, you have to place a routing protocol including the RIB groups or under the RIB groups. But policy, you can just create the policy. So see the example here. So you create one policy here. Policy name is ISP import and from instance master then accept. From instance master then accept. That means this policy matching master route table and go to the routing instances, and import the instance import this policy under the routing instances. Basically, they copy the master route table to custom routing instances or custom route instances. And this is the output. So if I check this one, so first create the policy. So edit policy option, policy statement, or you can see run show routing, run show route instance. See here the multiple routing instance master means inet.0 and inet6.0. This is the master route table. I'm messing here in policy. The instance is master. Master means global route table. Okay. And primary path, this is the custom routing instance, and secondary path is custom routing instances. Okay. So create, edit, policy option, policy statement, ISP, I said here in ISP and set from 100 from instance. This is the instance, routing protocol instance. From instance, you set the instance name. From where you will get the instance name. This is the instance name, master, primary path, secondary path. So I copy the master routing instance. from master routing instance, then accept. TS, then accept. If route is coming from master routing instance, those will be accept. Okay. Exit and go to routing instances. Routing instances. Your routing instance is primary path and set here instance role and routing options under routing options. Routing options, routing options and import, instance import, instance import, and see here your policy is ISP import. So set this one and delete the RIB groups. Edit routing options. Show display set. Just deactivated interface routes or deactivated the RIB group or delete this one. We already checked this one, so delete the interface routes, delete this one, and delete the RIB groups. Group is delete this. So there is no RIB groups here. Okay, comment this one. Just check the route table now. I copy only primary path routing instances. So run show route table. My table is primary path and dot zero. See here, default route and other route is coming here. Okay. And another one is secondary path. Secondary path route table is not installed here because we yet not copy the routing instances under the secondary path routing instances. That is the reason. So go to the secondary path, select the same one, routing, set routing instances, routing options, instance import, and the policy is ISP import. So this is very simple. And commit this one, check the route table, run show route table. See here, secondary route is coming here. And if you check this one, default route and another interface route is also coming here. And if you check the packet, choose the secondary path. B1 is choosing secondary path and A1 is choosing the primary path. Okay, any confusion? No, right? Okay. So filter-based forwarding have multiple options. You have multiple way to do this. One or first way, you can configure next IP. Then you can configure next interface. Then you can use RIB groups, including firewall filter and routing instances. And last one, if you don't interested to create the RIP groups, then you can import instances under the custom routing instances. So that's all for today, I think. See you in next class. Thank you. Allah Hafiz.